Hello, data wizards and statistics enthusiasts. Today we're diving into the captivating world of probability distribution functions. This fundamental concept might seem complex at first, but don't worry. We're here to simplify it for you. So let's start at the very beginning. What is a probability distribution function, commonly known as a PDF? Well, in the simplest terms, it's a function that describes the likelihood or probability of different outcomes in a statistical experiment. Think of it as a guide, a map if you will, that shows you where you could end up in a landscape filled with statistical possibilities. Each point on this map represents a potential outcome, and the PDF indicates just how likely you are to land on each of these points. So, in essence, a probability distribution function is your trusty compass, guiding you through the exciting, sometimes unpredictable terrain of statistics. Picture it as a map that shows you the probability of landing on each possible outcome in a statistical landscape. Now let's take a real-world example. Imagine rolling a fair six-sided die. In this scenario, we have 6 possible outcomes, namely 1, 2, 3, 4, 5, and 6. Each of these outcomes is equally likely to occur, meaning the probability for each is 1/6. This is our probability distribution function, or PDF. The PDF here is a flat line at the height of 1/6, showing the equal distribution of probabilities across all outcomes. Now think of this PDF as a pie. Each slice of the pie represents an outcome of the die roll. The pie is evenly divided into 6 slices, so each slice is 1/6 of the pie. This pie is a visual representation of our PDF. Each outcome or slice has an equal chance of happening. So, when you roll that die, each number has an equal shot at being rolled. It's like having an equal slice of probability pie for each number. Did you know there are various types of probability distributions? Each of these distributions fits different types of data, much like how different keys fit different locks. Let's take a closer look. First, there's the normal distribution, also known as the Gaussian distribution. Picture a smooth bell-shaped curve, high in the middle and tapering at the ends. This distribution is commonly used when dealing with data such as heights, weights, or test scores, where most of the data clusters around the average, with fewer outliers on either side. Next, consider the binomial distribution. This one comes into play when you have binary outcomes, like flipping a coin. Will it be heads or tails? With only 2 possible outcomes, the binomial distribution helps us understand the probabilities involved. There are many more distributions out there, each with its unique shape and application. From test scores to coin flips, different distributions have you covered. You might be wondering, why are probability distribution functions so important? Well, they are fundamental tools in the fascinating world of statistics. They offer a way to predict outcomes, calculate risks, and make informed decisions. Think of them as a statistical compass guiding us through the landscape of data. Let's say you're a meteorologist. You'd use PDFs to forecast the likelihood of different weather conditions, or perhaps you're an investor. PDFs would help you understand the potential returns on your investments, guiding your financial decisions. But it's not just about predicting the future. Probability distribution functions also help us understand the past. They allow us to analyze data, identify trends, and draw insights from the world around us. So whether you're navigating the stock market or predicting tomorrow's weather, probability distribution functions provide a powerful lens for understanding our complex world. From weather forecasting to stock market analysis, probability distribution functions are powerful tools for interpreting the world around us.